Hello, this is Charles Rarick. I'm the director of the storage practice for Commercial Data Systems in Albuquerque. CDS is an integrator and value-added reseller of virtualization technology. And today we're going to talk about our virtual schoolhouse solution. It's important to note that while most of the comments I have will be directed towards the classroom, those same technologies and benefits we talk about in virtualizing the desktop in the classroom can also be applied to the administrative back office. I think it's fair to say that the most expensive piece of rolling out PCs to the classroom is the administrative component. That is setting up the PCs initially, loading operating systems and courseware, patching those operating systems over time, providing needed security, backing up the courseware, backing up the student data, etc. And furthermore, if you have student courseware and data actually installed on classroom PCs, student access to that courseware and their data is limited to the time that the student is in the classroom. So happily, with the new era of virtualized computing technology and thin client technology, we have the opportunity to solve the majority of these problems. So the purpose of this presentation is to explore how a carefully conceived architectural approach using leading-edge storage and server virtualization technology along with thin client technology can yield a very cost-effective and flexible classroom computing environment. Over the next 30 to 40 minutes, what we'll cover are some of the key considerations regarding classroom computing, the problems we're trying to solve, what we're trying to achieve. Being good IT people, we at CDS have come up with our own acronym. We call it MAVEN. This is Multiple Application Virtualization Environment, and this is the architectural approach that I'll be spending some time on to discuss how to establish a proper virtualization environment to support the virtualized desktop in the classroom. We'll talk about what are the components that are needed to do a virtualized desktop environment for the classroom. Do a little head-to-head comparison of the pros and cons of a virtualized classroom environment versus conventional PCs. And then we'll talk about some of the financial implications, total cost of ownership and return on investment study relative to replacing PCs in the classroom with virtual technology. The fastest growing area for the IT industry is around virtualization. People have come to understand that this stuff really does work. It's very elegant, and it's a great way to take a lot of servers that are running 5 to 8% utilized, take the applications off those servers and put them inside virtual machines, and then run multiple virtual machines on fewer physical servers. Not only do you boost the use of the resources you're paying for, your servers, from 8% up to 50 or 60 or 70%, it does much to green your data center. There are significant benefits and reductions in space, power, and cooling associated with virtualizing the data center. So those folks that have realized significant benefits from virtualizing their server environment are now turning their attention to the desktop. And there's no place that probably can benefit more from virtualizing the desktop than in the classroom. So the key here is to get the courseware and the student data off the desktop and move those back into the data center for centralized control and management. By doing so, we can significantly reduce the administrative burden of desktop support. We can increase the security, and we can provide remote student access to the courseware. We can also then automate the backup and recovery of courseware and student data much more efficiently than we can with data out on PCs or departmental servers. And we can use cloning technology, which will allow us to very rapidly deploy new courseware to a wide number of students almost instantaneously. So in order to pull this off, what we need is a very disciplined architectural approach to make sure that nothing falls through the cracks as we roll out our virtualized desktop environment. Our approach to that is called Maven. And what we're trying to accomplish here with Maven is a true end-to-end centrally managed architecture. In other words, we want to centrally manage all of our critical servers, our desktops, our databases, our applications, etc., including out to the very end desktop environment in the classroom. We want to be able to rapidly back up and recover every critical element of our IT infrastructure, not just the data, but also the virtual machine images, the operating system images, the applications, etc. And we want to be able to automate these functions. Most schoolroom or schoolhouse environments are fairly strapped for enough resources, enough people to manage these environments, and the degree to which we can automate the backup and recovery of all of our critical IT elements is very important. When most organizations start to consider virtualization, the thing they typically focus on is server virtualization or desktop virtualization. They may spend some time thinking about the capabilities of their network, but in many cases they leave the consideration of their storage infrastructure for kind of the last thing. At CDS, we think that's the most important thing. As you move to a virtualized infrastructure, in order to take advantage of the primary benefits of virtualization, you have to move away from direct attached storage and distributed storage and move to a network storage model. In other words, you're putting all your eggs in one basket. All your operating systems, applications, data, etc. are going to be housed in centralized network storage. So as a consequence, you need to really guard that basket. Happily, there's a new technology in the marketplace called dual parity RAID, which will protect against what's called a double disk failure. Double disk failures are becoming more and more problematic as disk sizes get larger and larger. And dual parity RAID protects against those and against the loss of a file system. So that's one of the technologies that needs to be considered when looking at storage for your virtualization environment. The second one, as noted on the slide, is a unified architecture. And what this means is the ability to serve up fiber channel, SAN environments, iSCSI, NFS, and CIFS for file services, HTTP, every protocol type from a single product, from a single unified interface. Doing so can substantially reduce the cost of ownership of your storage infrastructure and the management of that infrastructure over time. Thin provisioning is a key requirement when moving to a virtualized space. Thin provisioning is to storage basically what virtual machine technology is to servers. In other words, creating a resource pool that can be used as needed. In a conventional storage environment, I pre-allocate storage, and I only get about 35 to 40% utilization of my storage using this approach. With thin provisioning, I have the ability to basically put all my storage into one pool, and then I only dole that storage out as it's actually needed. By doing this, I really can double the amount of use I get out of my storage. In other words, I can drive my utilization from 40% up to closer to 80%. Snapshot technology is something that you need to consider, and it's something that I'll be referring to on several occasions. Basically, snapshots are point-in-time, pointer-based backup and recovery mechanism, and there are a lot of manufacturers that offer this technology. The thing to be aware of is they're not all created the same. In many cases, if you get more than 3 or 4 snapshots on the system for a given volume, the performance of the system will suffer. If, for example, you want to be able to back up all your student data at the end of every class period, you need to have a system that has snapshot technology and capability that allows for that kind of frequency in snapshots. So to look at the snapshot technology that's available from each vendor is a critical component. Finally, deduplication is very important. Deduplication is the notion that the system will basically take and look at all of the blocks of data and compare all those blocks of data against each other and reduce or eliminate the redundant blocks of data. This is particularly important in a virtualized desktop environment because when I roll out virtual desktops, those desktops are basically clones of the parent. And the same information, the same operating system and application binaries get copied over and over and over. And left to its own devices, virtualization can waste a tremendous amount of disk storage by saving this same duplicate data over and over. So deduplication on primary storage is critical to be able to get rid of those duplicate copies. After considering the storage architecture, then we'll move to consider the operating systems, the servers, and the desktops. And at CDS, we're fairly agnostic. If you're a Windows user or a Unix user or Linux, if you like Sun or HP or IBM, if there's one brand of thin client you like over another, that's just fine with us. We can help you integrate those different technologies into the environment that you need. The third thing we always consider then is the network. As there are a wide variety of thin client models out there, the network that you have may or may not be sufficient to support those. For example, at one end of the spectrum, in terms of thin client technology, it's basically a PC that's just had the hard drive removed. It still will do most of the local processing, or I should say most of the processing locally and most of the graphics rendering locally. At the other end of the spectrum, we have very thin client technology, which is basically a way to attach a monitor and a mouse and a keyboard, and most of the processing and rendering of graphics is done back centrally. In that case, there's considerably more demand placed on the network for transferring this data back and forth between the central processor and the thin client. So not only do we need to consider ourselves with the performance aspect of our network, we also need to make sure our network is highly available. Once we have considered the network environment, we need to now look at the virtualization suite. I'll use terms that were brought to the market by VMware. They have the oldest standing current virtualization technology in the marketplace. There are a number of other competitors now, like Hyper-V from Microsoft. Oracle has virtualization technology, so does Citrix. And they all offer varying degrees of capability at different price points. But to use the VMware terminology, one of the nice features that's available with virtualization is what's called DRS, or Dynamic Resource Scheduling. Let's say we have two physical servers, both running a bunch of virtual machines, but one of them is, say, 80% utilized, while the other one is 30% utilized. DRS can invoke a tool called vMotion, and non-disruptively on the fly, while users are still using their virtual machines, they can move those virtual machines from the oversubscribed server to the less utilized server and balance out the workload. I can also use this tool manually, if you will. I can quiesce a physical server, add memory, for example, test that memory, bring the server back online, and then non-disruptively move virtual machines back over to that server. One of the most compelling things that's come out recently in this arena is a thing called distributed power management, or DPM. As you are well aware, in the evening the staff goes home, the students go home, and yet if my servers are still all up and running, they're drawing a lot of power and producing a lot of heat and actually benefiting very few people. So with distributed power management, it also can invoke these underlying capabilities of vMotion and DRS. And over time, as people leave the schoolhouse and the workload on the servers becomes less and less, it will automatically migrate the running virtual machines to fewer and fewer physical servers and put most of the servers into standby mode. So overnight they're drawing maybe 15 watts of power instead of 215 watts of power. This component by itself can save you a tremendous amount of electricity cost. Finally, virtualization does provide for very elegant and cost-effective high availability capabilities where if you have a physical server that fails, the system will automatically restart those virtual machines on a still running server. With these four basic building blocks then as our architecture, the storage, the systems and operating systems, the network, and then the virtual machine layer, now let's go back to the original premise of being able to back up and rapidly recover every critical element of my infrastructure. Using the snapshot technology I mentioned earlier,